I think we're live. Hello, everyone. Welcome all on Data Phoenix webinar. Today, we will speak about data, about problems which you can have with AI system. And with us, Emmanuel Turlay. He's founder and CEO of I, Art,
Airtrain.
Airtrain AI. He will do today the presentation and share him knowledge and him thoughts about data and why you need to have high quality data for your system. You can ask your question using Slando. It's the link is under the video, and welcome to our chat and write your comments through our webinar. So, Emmanuel, I give you a microphone.
All right. Well, thank you so much, Dimitrio, and thank you so much for having me. I'm a big fan of Data Phoenix, so it's really great to be here. I'd also love to hear about everybody that's on the webinar here, so feel free to post your name in the chat, maybe where you're from, what you're working on, and if you have any questions, there's the Slido thing to ask questions. So today I'm going to talk about the question of data in the context of AI. It turns out, even with this new wave of GenAI, the crux of most problems still lie within data. Before ChatGPT, in the old machine learning and data science world, already most of the problems were due to data quality, and I have seen that throughout my career. And it turns out with AI systems, things haven't really changed. It is still the crux of the problems. So what do I call AI systems? It goes all the way from training foundational models, fine-tuning models, evaluating models, but also evaluating AI apps. So for example, if you're building an app on top of an AI model, maybe you're using an API, like an OpenAI API, and you're building an app on top of that, you need some way to evaluate your product as well. So it could be like a chatbot, could be a RAG pipeline, could be an agent. All those systems need to have some sort of data loop in order to evaluate them. So this is what I'm going to talk about today. So first, a few details about myself. So I'm originally from France. I started my career about 15 years ago. I did a PhD and postdoc in particle physics at CERN. Then I switched into tech and worked at Instacart for about 4 years. I'm sure you know Instacart, grocery delivery company. And this is where I learned a lot of good practices around curation of data and centralization of data. And then I moved on to work at Cruise in 2018. Cruise is a self-driving car company based here in San Francisco, where I started the ML infrastructure team and worked on a number of frameworks to help people process large amounts of data, orchestrate their data and training pipelines. And eventually in 2022, I left Cruise and started Airtrain AI. And our focus at Airtrain is to build tooling around LLMs, notably on evaluation, fine-tuning, and data curation. So that's the high level. So let's get into the thick of things. Why are state-of-the-art LLMs so good today? So if you go use ChatGPT or Claude or Mistral, any of those models, they are surprisingly good. They almost feel like there's a real person behind them that is talking to you. However, those LLMs are not really capable of actual reasoning. It's not general intelligence, super intelligence. However way you want to define those things, those models are not it. What they are very good at is to replicate patterns that they see in their own training data. So essentially, they are systems that approximate their training data. So why are they so good? Well, essentially because they were trained on a large amount of very high quality data. And to prove this point, we can take a look at the article that Meta published when they launched Llama 3 a few months ago. And here they mentioned that Llama 3 is pre-trained on over 15 trillion tokens being roughly words, that were collected from publicly available sources. So 15 trillion token of essentially web data. And so if you read it further, you can see Llama 3 is trained on data of the highest quality. They use heuristic filters, NSFW filters to remove toxic content. semantic deduplication to make sure that you don't have overrepresentation of certain types of content in there. They trained other models to predict the quality of certain pieces of content that they use for training. And they also made sure, if you look at the last highlight here, mixing data from different sources in our final pre-training data sets. So a good balance of code, of academic data, of tutorial data from the web, all sorts of very high quality sources of data. Another example of this is the Phi-3 model coming from Microsoft. So Phi-3 is a very small model, but performs exceptionally well for its size. And if you look at the abstract of the technical report that was published by Microsoft, you will see that the innovation lies entirely in our data set for training. So this means that the architecture of the model itself, the hyperparameter of the models itself, of course, are important. But what they say here is that the most important, the biggest lever that they have to make models good is to use high quality data sets. So they use a scaled up version of the one used for Phi-2, which is the prior generation model, composed of heavily filtered, publicly available web data and synthetic data. So if you go look at the Phi-2 and Phi-1 paper, they explain that they really filter their training data to use what they call textbook quality data. So essentially things that you could be using in a college class, for example. And then they use synthetic data to augment this data, multiply it to make it bigger and augment the diversity of it. So these are for the foundational model. But this concept of high quality data applies to almost everything in AI. So even if you're not training a foundational model, you should care about the quality of your data. So just for the joke here, as I was preparing this slide, I was trying to generate some illustrations for some of the points that I was making. And so I put this prompt into GPT-4o. Please generate an abstract image to illustrate the following statement: top problems to put AI systems in production. And this is what GPT-4o came up with. With this abstract image. But what's important here is that the term data quality is repeated 3 times in this image. And I didn't prompt GPT-4o to mention data quality. I just asked what are the biggest problems to put AI systems in production. And GPT-4o basically said that data quality is one of the biggest problems. So it's not just me saying it, it's the model saying it, and the entire industry as well is saying it. So I encourage you to really care about that. So what are the biggest problems to put AI systems in production? At Airtrain, we work with a range of customers, from early stage startups all the way to enterprise customers. And what we notice are the biggest problems to go from a prototype that maybe you've built internally to prove some value to actually moving this product to this prototype to production. So one of the biggest problems is quality and reliability. When you test your AI product on a few examples, by yourself or with your team, maybe it works fine, but is it actually going to work fine in production when real users are querying it? So the quality of the output, reliability, it's not because the model is performing well once when you do your manual test that it will always perform well. Those models are non-deterministic. There's a stochastic aspect to them, which means that the same query can return different results. And so how reliable are those models? So the problems in terms of quality is like relevance, factualness of the responses. Is it really the actual response? Hallucinations are a big problem in the AI systems. Is the answer relevant to the question that the user asked, and so on. Also, consistency. Is my system going to always return the same type of responses for the same type of query? Can I reproduce the same results? That's definitely is a big problem to trust your prototype to go in production. Then safety is another big concern. So you want to make sure, obviously, that your system is polite with its users. Offensive content that has the correct tone that you want. If it's a casual system or a more formal system, you always want to make sure that your model respects the guidelines that you gave it. So that's another problem to worry about. Obviously, toxicity, harmful content. You don't want your system to insult your users or to tell them harmful content. For example, if you're building an AI system in the healthcare space, it's very important that your model does not give wrong indication to your users. So all of this is a big concern before you put your model into production. Also, if for example, there was a big story in the news a few months ago of this chatbot, this customer chatbot. I think it was Delta Airlines that was giving away lots of discounts and vouchers to its users. So that could be a major safety concern for a company if suddenly your model starts taking actions that it would not allow to take. So that's another concern to worry about. And then another big bucket of concerns is cost. So those big models are quite expensive. If you build your prototype maybe with GPT-4o or any of those top-of-the-line models, they're actually quite expensive, which is fine when you have low volume in your test environment. But as soon as you go to production, you're going to have a huge bill, whether it's Anthropic or OpenAI or any of those APIs. Your bill can get dramatically large. So there's been a few stories out there of people launching AI apps and getting viral overnight and waking up to a $10,000 bill the next day. So this is definitely a major concern when you bring things to production. So these are kind of the three buckets of issues that we've seen with our customers when they want to move from prototype to production. So solving those problems entirely is kind of a moot endeavor. However, you can definitely try to mitigate them. So in this talk, we're going to see how we can mitigate those issues to have a little more trust and confidence when we move those products to talk to real users. So when we talk about quality and reliability, how can we raise our level of trust here? So the first thing to do is offline evaluation. So I will talk more about this in a minute, but essentially that's things that happen before you move your product into production, testing it, whether it's manually or using a test suite, but doing this offline evaluation to make sure that it's subscribed at least to the high-level guidelines that you've set up for your product. So then once you have offline evaluation and this is satisfactory to you and you deploy it in production, monitoring, which is sometimes also called online evaluation, meaning tracking what's going on in your app in production, tracking the actual conversations, tracking some metrics around cost, around quality of the responses, toxicity, and so on. So you can have data to analyze the behavior of your app and try to fix it. So these are the things that you can use to mitigate the quality problems, and I'll dive into those in more details. And then for safety, again, offline evaluation, you can set up your offline test suite in a way that mitigates safety problems by adding more and more test cases that kind of try to test the boundaries of the corner cases of your model, see how your model responds or your system responds to those types of unsafe queries. And then for cost, one of the techniques to reduce cost is fine-tuning. I'll talk a bit about this at the end. It's one way to get cheap models to perform as well as large models on specific use cases is fine-tuning. And again, high-quality data is necessary here. So, and then for cost, even if you're not fine-tuning, obviously tracking your spending every day, tracking how much, how many tokens you're consuming, how many, per user, per request, all those details to figure out exactly what is your consumption of AI models every day. So we're going to dive into all those aspects in the next few slides. So let's first talk about offline evaluation. This is probably the most important thing you should be doing. There's many ways to go about it. You could be doing something manually. This basically offline is before you deploy your system. So you run, it's kind of like a CI pipeline. When you're developing an application, you run a suite of unit tests in your CI pipeline. So Circle CI, Travis CI, any of those. And on every commit or on every push to your version control system, to Git, for example, you can tell if your new code, if your changes have broken the existing test. So you should think about offline evaluation sort of in the same way. You should think about offline eval as part of CI. You want to run your application through a set of test cases to make sure that there is no regression. So one tricky part here is that when you do CI, you have a pass-fail, green or red, if the test has passed or not. It's binary. It's very easy to know if your test suite has completed successfully or not. In the case of AI, there is no such thing as pass-fail. You have metrics that tell you, if it's better or worse. If it's worse, is it an acceptable regression compared to the benefit that the new feature brings? So it is not as trivial as an actual, CI pipeline of unit tests to evaluate. So you need to have like a human in the loop that observes results of your offline evaluation and makes a judgment call to figure out whether or not this update, this changes to your code or to your prompts are safe to push to production. So the first thing to do if you want to enable offline evaluation is to curate a data set for evaluation. So typically, it could start with a few dozen examples. You could create it by hand at first, and ideally you would grow it to a few hundred, a few thousand examples. And this has to represent as closely as possible your production data. So you have to test, obviously, the happy path. So if somebody comes into your app and asks the right questions in the right way, you should obviously test that to make sure that the main functionality of your app is satisfied. But you also should take care of the corner cases. People may not be interacting with your product the way that you anticipated that they did. So you need to figure out how they are interacting with your product and extract those as corner cases so that you can treat them. Maybe you need to augment your system prompt to make sure that those corner cases are taken care of. And then I encourage you to also do a Pareto analysis of failure modes. So this is only possible once you've collected enough production data and you've seen through monitoring, you've seen how your app is failing. So you can classify your failure modes. So maybe there's a class of failures where your prompt does not even know how to respond to users. And maybe there are some cases where your system is responding incorrect generations. And so a Pareto analysis essentially is identifying the biggest bucket of failures, the most impactful buckets of failures in your system, and addressing them one by one. So you can sort all those failure modes by the most impactful, the one that are leading to the most loss of revenue or dissatisfaction of your users, and start to create test cases for those problems. So once you have your evaluation data set, you need to establish what's called an evaluation harness. So determine metrics that are important to you. How are you going to measure pass or fail? As I just said, in the case of a suite of unit tests, it's easy. It's all the test passes is green. Any test fail, then the test suite is red. In the case of offline evaluation, you will not necessarily get a pass or fail. You will get a metric number. And so you need to evaluate what is an acceptable metric for you to be comfortable pushing your system to production. So some very high level metrics could be just heuristics, things like the length of the generation. If you want your system to be more prompt or to be more sort of compact or verbose, you could test on that. Also, you can test for the content of certain words in the output of your models. So if you want the response from your system to always contain certain terms, you can obviously search for those in the output of those generations. This is not the most powerful way to do it, obviously, because the output is not deterministic. So another technique that has kind of emerged over the last few months is LLM as a judge. I'm sure you've heard of this technique before. You essentially feed the output of your AI system to a judge model, typically a high quality model like GPT-4, for example, and you prompt the model to establish a particular metric out of it. So it could be, how faithful is the response, the generated response compared to the context that was given, how relevant is it, how polite it is, how toxic it is. And so you can get another model, your judge model, to score your output either on a binary scale, like is it safe or unsafe, or on a Likert scale, like from 1 to 5, or any of those kind of scoring mechanism. It's up to you to decide which one works for you. And so that can give you a bit more of a quantitative sense of how your system is performing. And then if you actually have ground truth, meaning labels, so for example, for all the test cases in your evaluation data sets, maybe you have an ideal response that you've maybe wrote yourself or used from an existing production case. And in that case, obviously testing exactness, an exact match, it's probably not going to work because, as you know, models always generates variation of the same answer. But there are metrics like the Levenshtein distance, for example, that can measure how close a generation is to a ground truth. So if you have ground truth, you can do those additional checks. So this is offline evaluation, and this is probably the first thing you should set up when you want to go to production so that you can feel safe pushing updates to your system without worrying too much about breaking things. The same way that a CI pipeline is your safety net when you're pushing code to production. Now, the problem with offline evaluation is that it can become quite expensive. For example, if you use LLM as a judge methods, every time you run your eval test case, let's say you have 100 cases in your eval data sets, you're going to query your judge model, which, because it has to be a good model, is typically quite expensive, with the test generation, but also your system prompt. And so doing this, maybe on every commit, the same, or every push, the same way that you do with CI, may be prohibitive. So generating the responses, calling the responses, all of this can be quite expensive. So you have to devise a strategy to not do this all the time. So maybe when you push PRs to when you push commits to your PRs on GitHub, for example, you can set up a smoke test. So you can identify a minimal subset of your evaluation data sets, maybe just a happy path, for example, the happy path and a couple of high profile, high impact corner cases, for example, and only run those. And maybe it costs you a few dollars every day, and that's an acceptable expense for you. And then before you actually want to deploy to production, so you should probably run your full test suite. So that's the one that potentially is a bit expensive, but if you deploy to production maybe a couple times a week or every couple of weeks, then maybe it's an acceptable cost for you. And this is where you establish what are your criteria as an engineering team, as a product team. What are your criteria and your threshold to greenlight your changes? So as I said, in the case of a CI pipeline, it's pretty a unit test pipeline is pretty easy. It's pass or fail. In this case, in the case of an evaluation data set, you probably need to figure out what is the sort of metric threshold that are acceptable to move my changes to production. So, for example, this could be part of your pipeline on GitHub. When you push your test to your code to GitHub, typically you have a bunch of things that are happening, GitHub actions that are happening, maybe running your unit test and so on. Part of this could be running your smoke test. So maybe a couple dozen examples that are querying your judge model to establish the quality of the outputs, and maybe you have a way to report those results inside of your GitHub PR page to get a sense of how impactful the changes that you made are. So this is for how to get started with offline evaluation. Now, as I mentioned, the crux of your offline evaluation is your evaluation data set. And this will, the bigger your evaluation data set, the more powerful it is, and the more you can catch issues, the same way as a unit test pipeline can do. So I would encourage you to just get started. Maybe pick out a few examples. You probably have your own manual examples when you're building an AI app. You probably already test your app yourself, before pushing it. You maybe have 5-10 prompts that you're always running through your app to see how it works, if the changes were impactful in a good way or not. So this is the seed, this is the basis of your evaluation data set. So just get started with a handful of examples, store your manual test prompts, manually check the results. This is already great practice, and this is the start of your evaluation data set. So from there, you can start augmenting your evaluation data set by identifying common failure modes in your application. So observe through monitoring the way that your users interact with your product. And every time you see a failure, extract the prompt that triggered the failure. This is a great use case to add to your evaluation data set. And you can define, how can I identify those failed responses? Maybe there's a term in there that is really bad, maybe a toxic term or a swear word or something like this. So you can already start building up heuristics around those failed responses and start building up your evaluation harness around those things. Now, once you have this initial set of data, maybe a few dozen examples, you can use synthetic data to augment your evaluation data set. And so synthetic data seems like a scary word, like how do I even generate this at all? Getting started is actually pretty easy. Doing this at a large scale, an entire data set is tricky. But getting started with a few low-hanging fruit is actually not so difficult. So for example, here on the right, I queried GPT-4o to generate variation of a particular prompt. So if you read the prompt, please generate 10 variation of the input below. Use various tones from formal to casual. Also includes typos and grammatical errors. Make it shorter or longer. And then I put the seed of the generation. So in this case, this would be an eval data set for healthcare medical chatbots. So the input is, I have a headache, a sore throat, I'm congested. Can you help me? And as you can see, GPT-4o has been able to generate 10 variations of the same question, some of them more formal, some of them more casual. And so you can see how you can design your prompt to generate for you with this synthetic data. And already we went from 1 example to 10 examples. And those 10 examples will prompt your system in different ways, will surface like stochastic variations in your results that can already help you catch issues and augment your evaluation data set. So as you've heard, I've often made this parallel between your offline evaluation and your pipeline of unit tests. So I'm going to make this comparison more precisely. So for all of you that are software engineers, you've been taught in school and all your jobs, you have to write tests, all the features that you are developing, all the code that you're pushing has to have test, unit test, functional test, and so on. So the way that you do test-driven development usually is if you find a bug while you're testing your app or in production, before you fix the bug, typically you write a test in your test suite to reproduce the bug. Obviously, the test is going to fail. That's the purpose of writing this new test, because there's a bug in your app. Then you fix your bug, the test passes, and then now you have an additional test in your test suite that you keep forever, and that increases the surface of your test suite and increases your safety, your sense of safety and confidence in shipping into production. If you have an application that is very well tested, you can move very quickly. You can ship updates and changes very quickly without worrying too much about breaking things, because you know that your tests are going to catch this. And so when all your tests are green, you feel safe to deploy to production. This is how you could have automated deployment almost every day, every week, push to production without worrying too much about testing manually, because your test suite has taken care of this. You should probably think about offline evaluation in the same way. So if you're building an AI system, so an AI app, a RAG pipeline, or an agent, or any of those variations, you can identify in production or in test bad model responses or bad behavior in your AI app. So ways in which your app is failing. You can extract the types of prompts that are generating those errors and add it into your eval dataset. This is the same as writing a test for the bug. Then you can iterate on your code and your prompt to make sure that this failure does not occur anymore. So this is not a foolproof guarantee. Your failure can occur again, but at least you limit it. Once you have this new entry in your eval dataset, you keep it forever, and you grow over time. You grow your eval dataset by adding more and more cases that are the ones that you identified in production. And so essentially you can see your eval dataset as the same as your unit test suite that you run on every PR. So I encourage you to think about offline evaluation in the same way. So as I mentioned, a great way to start building your evaluation dataset is to do monitoring. So you should probably log everything that happens in your app. So the user inputs, the model outputs, the returned responses that you gave to your user. If your app has multiple steps, if you are querying multiple models, if you are doing retrieval as part of a RAG pipeline, you should probably track all those things, all the things that were generated, all the intermediate steps that are being used by your app. You should track all this, persist it. So either do this yourself, persist this in your own database, or use a logging system to do this, or there's a bunch of commercial products out there that let you do LLM trace monitoring as well. Then you obviously need to track key metrics, things that are very important for you in your business case. So it could be just the cost, for example, how much you're spending per day on the AI APIs that you're relying on. It could be the speed, throughput, latency. For some application, this is actually quite important. For example, voice applications, if the latency is too high, the user is going to become frustrated, and so you're dissatisfying them. So maybe this is something that you should be tracking. Then maybe some metrics. For example, you could be using some of those LLM as a judge metric to judge whether an output was relevant or toxic or polite, any of those high-level metrics. Obviously, you should choose metrics and design them carefully according to your business case. There's no one size fits all here. But also be careful about the cost of those metrics. As I explained before, because you're prompting a model every time, this could be costly. So you may need to do some sampling of your production, depending on the volume that you have. If your application has low volume, maybe you can evaluate every single interaction with your users. If you have very large volume, you may need to do some sampling and trust that the sampling will represent fairly the usage of your products. So once you have set up your online evaluation, your monitoring, you should use this as the seed of your offline eval data set. You can try as much as you want to imagine how your users are going to interact with your products. But at the end of the day, the most faithful source of data for this is the actual interactions of your users with your products. So use those as sources. Now, maybe you'll see an exceptional good interaction. It's like, oh, this is a great test case. I'm going to add it to my offline eval data set, or other way around. This was very bad, and so I need to fix this, and so I'm going to add this test case to my to my data set. So really, this is important. Track everything, measure the performance of your product in production, and use this as the basis of your offline eval data set. Now, how do you go from this online eval system of where you track everything to your offline pipeline? So your eval data set has to look as close as possible to real world usage. So you can come up with as many test cases as you want from your imagination or use synthetic data. But at the end of the day, you need to look really how your users are using your product and extract those pieces of data. So as I mentioned, your production traces are your most faithful data sets. So obviously there may be a lot of noise. There may be, for example, 80% of the traces could be the same types of questions. And so you definitely don't want to extract all of your data sets. So there's probably a lot of noise. So you have to extract signal from noise. So honestly, I would encourage you at first, especially if your volume is manageable, to look through all those interactions by hand. Look at all of them. Sit down for an hour, 2 hours every day. Look at how your users are using your app. Go through each row, see how the model responded. This will teach you a lot about the quality of your system. Then you can use tools to explore larger amounts of data. So if your volume is too large to explore by hand, you can use tools. For example, Airtrain AI, I'll show you at the end of this presentation how you can use it, are useful for this. But there's other tools out there. And then the type of signal that you want is high quality interactions. So basically the happy path. You need a few of those, obviously, to test the main functionality of your product, but also the failed interaction, as I mentioned. This is probably actually even more important than the happy path. How is your system failing? So many systems out there, AI systems, are based on RAG. I'm sure you are all familiar with RAG, retrieval augmented generation, where essentially you first use the user query to retrieve a number of chunks that are relevant to the question that the user is asking, and then use those chunks or those documents to generate a final generation. So you can see RAG as really two pieces. There's the retrieval part, which is akin to a usual search algorithm, ranking algorithm, and then the generation part, which is more a GenAI type of task. So you should test each component independently. So you should have probably an eval data set for your the retrieval part of your system, and an eval data set for the generation part of your system. So for example, for retrieval, you need a data set made of question and chunks pair. So for any question in my evaluation data set, I need to have a list of chunks that they should have, that the model, the system should have retrieved. And then from that, I can evaluate some metrics that you can see here on the right. So RAGAS is this popular open source data set for RAG evaluation. There's a number of metrics like context, precision, and recall to evaluate how good your retrieval algorithm is. Then and in terms of metrics, precision, and recall, on the generation side of things, same thing, you need a data set, but in this case, you also need the actual answers that were generated from the chunks. And once you have that, you can measure how faithful the answer is to the chunks that were provided, and also how relevant it was, and how faithful the answer was to the initial question. So here you have sort of two sub-evaluation to do, one for retrieval and then one for generation. So you need to build two data sets for those, because they may have different failure modes and different parts that are important to you. So I encourage you to look at this data set RAGAS that help you essentially generate those things. So here's an example of how an evaluation data set would look like for a RAG pipeline. A number of questions here, arbitrary questions like what is the balance of selenium, and then context chunks, a bunch of maybe two overly verbose information about that are kind of adjacent to the response. Here's 3 examples, and then these are the chunks that you will feed to your last generation step, and you have the answer on the right. So you should be building data sets like this so that you can evaluate all the parts in your RAG pipeline. So I mentioned at the beginning that some of the issues that you may have are around quality and reliability and safety, and the last bucket of issues were around cost. So I'm going to be talking about this now. So if you rank model by quality, and this is a chart from the website Artificial Analysis that compounds a number of benchmarks to rank models by performance. So here, as you can expect, on the left, the highest quality, GPT-4o, Claude 3.5, and so on. And then here on the right, we have models ranked by cost. So to the right are the most costly models. Claude 3 Opus is the most pricey, GPT-4o is a bit cheaper, and so on. Now, what's interesting to note here is that the models that perform the best, if we take those 5 models, the top 5 models here on the right, are also the most expensive models. That's maybe not a surprise because they require a lot of compute and resources to train, but that's the idea. So there's a mitigation for this, and that's fine-tuning. It's been proven before that you can fine-tune a small model. This is the Phi 1 paper from Microsoft, that you can fine-tune a small model on a high-quality data set, and you will get similar performance to the top-of-the-line models. So this is a way to reduce cost. If you have a high volume and you can't afford to use those off-the-shelf API, you can fine-tune models to reach similar performance. And so same thing for fine-tuning. The key to a good fine-tuned model is a high-quality data set. So probably should create your data set by hand. You can use prototypes using expensive models to generate a fine-tuning data set, but essentially the quality of your data set will dictate the quality of your model. So I think we're a bit out of time here. So I wanted to walk you through a case study that we had that we worked on with a customer. It was a healthcare chatbot, and essentially they wanted to replace GPT 3.5 with a small model. And so here at the top, we designed 4 metrics. These are LLM as a judge type metrics that are relevant to this particular business case. And with a very high quality training data set, we were able to prove that a small model like Mistral 7B performs just as well as GPT 3.5. So this is just to prove to you that if cost is a problem to you, there are ways to reduce it. And if you look through this cost analysis, essentially this is going to show you that using a small model like Mistral 7B compared to a large model like GPT-4o can reduce your cost by about 96%. Obviously, this is only valid if you have high volume. If you're still in the prototyping phase, if you don't have lots of user yet, you should probably stick with the off-the-shelf models. So I want to use the next few products. Airtrain AI is a tool to help you build those data sets that I mentioned, evaluation data set, training data sets. It helps you sort through large amounts of data to extract the subset of the data set that is interesting to you. So we offer data exploration and curation, but also we let you fine-tune small models using those data sets. And we also have a playground that lets you play with 28 state-of-the-art models. So I'm going to switch into another tab to give you a quick demo of our product up over here. So we support a number of public data sets that we ingested to kind of showcase the power of the platform. So I'm going to bring up, for example, here a data set of CNN articles. So we have here 50,000 CNN articles. This is a data set that we ingested from Hugging Face. And so one interesting thing about the Airtrain platform is that we automatically generate for you semantic clusters. So we iterate through data sets and try to identify semantic clusters. So in this case here, about 4,000 articles relate to, maybe make this a little bit bigger, relates to athletic achievement. So basically articles about sports. And here you have articles about Formula One, tennis, and so on. So these are things that we extract from your data sets. And then once you once you have those clusters, you can filter your data set accordingly. So for example, here, I'm going to add this filter. Excuse me. I'm going to add this filter. And so now I filter my data set only to look at Formula One articles, and I have about 700 of those. Then I can use other insights like the token count, for example, to filter maybe by longer articles. So here I have, for example, 20 articles that talk about Formula One, and I have a high token count. So you can use all those insights to filter your data set. And once you identify a subset of your data that is relevant to you, you can export this data set back into your application in a JSON format to perform evaluation on it, for example. So we have a number of public data set available that you can take a look at, and you can also upload your own data set, and we will automatically generate all those insights, semantic clustering, embedding projections, any other insights that we can extract from your data sets. And then you can upload your first data set for free and use that to create to start creating your eval data sets. So that's it for me at this time. Thank you so much for listening. I think there might be questions right now.
Yeah, we have some questions, and also I prepare some list of questions for discussion. Let's to discuss a little about your company and how you created, what the idea was in first stage, and to what product you come for now.
Yeah, for sure. So before starting this company, I was an engineer at Crux. I was a platform engineer building tools for other engineers, ML engineers or data scientists to use. So Crux, as a self-driving car company, needed to retrain models very frequently with new data coming from the road. So the whole online to offline pipeline that I described in the talk, we essentially use that all the time, where we had data coming back from the road every day, and we would do data analysis, data mining to extract failure modes, fix those failure modes, add those failure modes to our test data set, and so on. So building tools around that for the case of a self-driving car. Then I left Crux in 2022, and the idea was to bring sort of this expertise, this knowledge that I gained building tooling around evaluation, training, and compute to the rest of the industry. At the same time, the GenAI wave exploded with the launch of ChatGPT in November 2022. And so suddenly the group of people, the number of people that care about AI systems multiplied by 10 or 100. Before it was mostly ML engineers, but now anybody that is building a product on top of an AI API, an AI model, needs to care about data. And so we're trying to make those tools much easier, whether it's evaluation, training, data creation. We're trying to make those tools available to people that don't necessarily have like a master's degree or a PhD in machine learning. So this was the idea behind Airtrain AI.
Okay, I understand. Yeah, and you work with data, and what you can recommend to our participant, what technique to use for prepare this data, their data from rough to ready data sets to have good quality of their own data set?
Yeah, so I think one thing that is often overlooked is to just simply sit down and browse through your data and take a look at it with your own eyes. You can use all the fancy tools out there. It will never give you as much sense of what is in your data than if you actually look at it. Obviously, large data sets are not, it's not doable to look at them all. But most of the work of ML engineers and data scientists is not to optimize model architecture or hyperparameter tuning. Most of the time that they spend is looking at data. That was true for self-driving car models. It's true for LLMs. And so, first of all, the first advice is to just spend a lot of time getting familiar with your data. There was a quote by Andrei Karpathy, that one of the OpenAI engineers, as part of his tutorials, was saying you have to become one with your data. Essentially, you have to really feel like you understand deeply your data. So I would encourage people to do that. Then in terms of techniques to browse through large amounts of data, semantic clustering is a good way to understand the different parts of your data set and how big they are compared to each other. For example, while we were building Airtrain AI and ingesting all those public data sets, we realized that some of them had duplicate data or had a large fraction of data that was not supposed to be in there. But because those data sets are large, they were not created every row by humans, then obviously those things fall through the cracks. So semantic clustering, full text searches, regex searches for your data to identify niches or things that are a bit less common is also a good way to go about it. And then using embeddings can also be a good way to find, if you find one, for example, one toxic element in your data set, you can find other rows that are similar to this one thanks to embedding projection. So that's another way. But honestly, there is no magic wand to make your data better. Really the good practice is to just spend a lot of time with it.
Yeah, to spend a lot of time with data, to research it, to try to understand what is good data, what is bad. It sounds like culture in the company that you need to do this, you need to understand this. But how sometimes engineers don't like do this job, and how better way to promote this culture to try to analyze and do your data better.
Yeah, it's true. As engineers, we like to write code and ship new features. We don't like to spend our time looking at data. It is true. So what I do when I need to do something that I don't like doing is I gamify it. I make it kind of a challenge, if you will. So in this case, first of all, track everything. Track your production data and track metrics. As soon as you set up metrics that are important for you, and you will see that maybe your metrics are not doing so well, then this will give you an incentive to start looking at those things. So start tracking your production data, some metrics, cost, quality, any of those things, and then suddenly you will have an incentive to do it. And so make this part of your your team's workflow to look at those metrics every week and see how they can be improved. Something else that I've learned in my career is that if you don't have easy access to data, then it becomes really a hassle for anybody to do anything. It's too much work, and so people just don't even do it. So centralize all your data in a data warehouse. There's plenty out there. There's Snowflake, BigQuery, Redshift, any of those things. You can centralize all your data. For example, in large companies, usually there are silos. There's multiple databases for different systems. And so I would encourage you to set up ETL pipelines to offload all those databases into the same data warehouse so that you can have a relational graph between all this data and start seeing patterns in them. Once all your data is in the same place, even just a raw copy of all your Postgres databases around your organization in the same data warehouse will make it much easier to extract insights and to query across multiple systems. For example, when I was working at Instacart, we had different databases for the catalog data of products that we're selling, or for order data, like people making orders, or support information. But we would centralize all of them in the same data warehouse so that we can make queries across all those different dimensions. And that brought us insight that were not possible to extract otherwise.
Yeah. And other interesting topic is the scaling. When we scale our system, we have more data. What is a common issue with quality of this data?
Yeah, so the more data you have, the more you will start seeing the long tail, if you will, of things that happen in your production system. So things that happen very rarely, and so maybe those things are not that important because it's 1 in a million and it's not really that impactful. But sometimes the 1 in a million case can be very dramatic. For example, working at Cruise, self-driving cars is a pretty safety-first type of product. Even if 1 in a million miles there is a very bad behavior, this is not acceptable. So the only way to extract those long tail events is to collect a lot of data, because obviously those things occur rarely. Obviously, in order to make sense of this large amount of data, you need to have automated pipelines to distill or identify failure modes in your data. So when you start building your product, this is probably a good time to start thinking about what kind of things I want to extract from my production data. Start setting up those pipelines of extracting, doing data mining on top of your production data, so that when you have more and more data, let's say your app becomes an overnight success, or you have lots of growth. Usually when that happens, you don't have time anymore to build those pipelines. And so starting kind of seeding the work before things get crazy can help you identify those things once you get it at a high scale. But I think this is a bit of also an organizational problem. Leaders, directors and engineers need to allocate time to build the pipelines to allocate those things. Usually once those issues start affecting the business, whether it's revenue or user satisfaction or safety, that is when they will allocate this time. And so that's probably when you should start building those pipelines.
Yeah, and what tools can help with this to solve this problem and help manage all this data, all this metrics, the quality of data in large scale?
Yeah, so I mean, for data processing, things like Spark is one of the oldest kids on the block in terms of large scale processing. There's a number of other products out there. For example, I think one's called Google Dataflow that we actually used extensively at Cruise. That makes it easy to process large amounts of data. So that's useful. It's actually rare that people have that much data. Usually there's a bit like maybe a few million rows. And so in that case, just dumping things into a database and start making queries is useful. And in some cases, you can even hold everything in memory in a notebook, for example, using pandas, and then you start looking at your data in this context. So in terms of scaling, you should probably also start thinking about partitioning your data set into various types of users or sharding it. And once you have a sufficiently large data set, it's likely that all the cases, the happy path and the less common cases are represented. And so you can extrapolate by imagining that the larger data set will have the same thing. But maybe it's the part of the process is as a team, every week somebody spends half a day looking at data, or one of the data scientists on the team spends some time doing that and reports to the rest of the engineers what they saw in the data. So I think scale itself technically is not necessarily a problem. There are tools out there to do it. It's more of a practice and a cultural thing.
Yeah, and other side for today, it's multimodal data is coming. Companies use different type of data. What challenges with this multimodal quality of data is for now?
Yeah, I mean, that's definitely a very big challenge right now, because most of the tools that people have been using for a long time, like, SQL-based data warehouses and so on, do not let you easily query across modalities. It's very hard to even run a query on an image data set. So that's definitely challenging. So this is an area where embeddings can become quite useful. Embeddings are essentially vector representation of arbitrary data. It can be text, can be audio, can be image. Obviously, as humans, we cannot make sense of an embedding. It's just a number of it's just some numbers, floating point numbers. However, you can use the vector space as a way to identify patterns. So for example, if you have found a number of problematic entries in your multimodal data set, you can use those entries embeddings to find other entries in your data set that have their embeddings close to this one, and that could be potentially problematic as well. So getting into the abstract space using embedding could be a way to do it. But I think the tooling is a bit immature in this space, because it's only now that we care about multimodal. For a long time, people were only looking at tabular data or just text data or image data, but across modality is a bit of a challenge. And so I expect the tooling in the next 6, 12 years, 6, 12 months, a couple of years to get better in that respect.
Yeah, and the question is of the future. How do you see the future of data quality in AI?
Yeah, so one big shift that has happened over the last 18 months, basically, is that as a software engineer, until now, you almost did not really need to care about data. You need to care about bugs, about things that are going wrong in your application. But extracting insights from data is the job of data scientists. Creating data sets is for machine learning engineers. As a software engineer, you did not necessarily have to care about that. But now the performance of your app depends on whether you're able to extract high quality data. So essentially, everybody needs to learn now how to look at data. Everybody needs to become a data scientist, essentially. So needs to learn how to use tools like, pandas, for example, to look at data, needs to have some way, needs to care about how their data is being collected and stored, and whether it's accessible to extract insights. So we can no longer, as software engineers, afford to ignore the data space. I think that's what's going to change dramatically. And already now in the AI space, the companies that are winning are the companies that are able to create the highest level data sets. Why is OpenAI winning? Why are those models so good? Because they have tools to extract the highest quality data. We saw the Llama 3 paper at the beginning of my talk. Llama 3 is so good because they were able to constitute a high quality data set. So this becomes a moat for people. Compute is getting cheaper and cheaper, so that's not necessarily the problem. But access to high quality data becomes the moat for many products now.
Yeah, we also have some questions from our participants, and if you have also questions, please use the link under the video and write it in the Slander, and we will ask it. So please define between high and poor quality data.
Yeah, so obviously this is extremely use case dependent, right? Every business case will have different definition of data. But for example, if you're looking to fine-tune a model, for example, and you're using data that's been crawled from the web, typically when you crawl the web, you extract text data, but also a whole bunch of HTML or JavaScript garbage, CSS, all that stuff that your model should not see. So this is low quality data. So parsing this data to remove all that and extract the signal, that's turning low quality data into high quality data. High quality data is what's going to teach your model the right things. Low quality data is noise, things that are going to make your model diverge or learn things that are not useful. But again, it's very use case dependent, and it's not high quality or low quality. It's always a spectrum.
Yes. Second, about strategy, please share the strategy to change poor quality data to high quality data.
Yeah, so you can definitely define heuristics as the use case I mentioned before. If you have garbled text in your garbled content in your data set, or garbage XML tags and so on, you can probably do some simple MapReduce job to run a regex across all your data and extract and remove tags that are bad. So just data processing to clean up your data is one thing, and then data labeling or fixing your data. So you can either do this manually if your data set is small enough, or you can pay your workforce to do this for you, to essentially go through your data set and fix it by hand, essentially. So go through each row, look at, okay, this content is not useful, I'm going to remove it. This content is useful, or this is garbled, I'm going to fix it. Doing this is very tedious, obviously, but it pays off in the long run because your data is pristine at the end.
Yeah, and more question about enterprise, and they have a ton of data. They don't know where and how to get started, chose the right amount to train ML models. What should be a start point?
Yeah, so the first thing is something I mentioned in my talk, is to first centralize data in one place. So start building up a data warehouse where you collect all the sources of data, and once you're there already, it's much easier for you to get started. Then start small. Start with a small data set of very high quality data. And so when you have a large data set, let's say 1 million rows, there's two strategies. You can say, okay, what rows do I want to remove? And so you start creating heuristics about, oh, I want to remove rows where this term is present, or talks about this, and so on. Or you can create your training data set by intentionally extracting the subset of your data set into your training data set. And this probably leads to higher quality data in the long run. So starting to identify, maybe a few dozen rows that are of interest to you, and finding others that are similar to those. So intentionally building up your training data sets. It turns out, in the context of fine-tuning, for example, you don't need that much data to fine-tune a model. With a few thousand, maybe at most 10,000 examples, if it's high quality, you don't necessarily need more data than that. It's even been shown by an academic paper that sometimes a few dozen rows can actually change the behavior of your model. So you don't need necessarily to have automated tools. You can just create things by hand in this case. So I would encourage people to start small and build up on top of that.
Yeah, we have several questions about tools for clean up data. What do you think about tools like CleanLab?
Yeah, so those tools are very powerful and very useful. I would encourage you to try them out. However, never think that any tool is going to be your magic wand that's just going to turn your data from low quality to high quality. You still will need to validate things yourself by hand, compare the output of what the tool has generated to what you would have generated. And so tools are great, but do not replace sort of human curation with tools. Tools are just helpful for humans. So I'm not familiar with white data, but same thing. I'm sure all those tools are very useful, but do not think that there will be magical silver lining that will solve all your problems.
And what do you think about UData for
Yeah, I'm not
curating?
with that one actually.
Okay. And more one question about, again, companies that they have a lot of files. They want to put all files to LLabs and wait for some magic. What important to have in the place regarding data quality?
So by throwing files to an LLM, does this person mean training a model on those files, or do they mean doing RAG on those files? I'm not really sure what they mean.
I think maybe RAG or yeah.
Yeah. But same thing for RAG. You need a high quality, the knowledge base on which you're doing your retrieval needs to be high quality. So first of all, you need to identify the articles or the documents that are actually up to date and relevant. Then you need to chunk those into paragraphs or subsets that are interesting. All this work is painstaking. So if you just throw blindly things at the LLM, the output is going to be not so great. There's this garbage in, garbage out saying, and everybody says it all the time, but it's true. So same thing. If you're trying to do RAG, I would encourage you to plan to curate your knowledge base data set to make sure that the highest quality signal can be extracted.
Mm-hmm. Yeah. So thank you for your time, for your presentation, for good discussion. Thank you for all who was with us. Don't forget to subscribe to our YouTube channel and join our Discord where we can continue this discussion. So yeah, thank you, Emmanuel, again for
thank you so much, Dimitri, for having me.
your time. Yeah, thank you, and see you all next time. I think next week on next webinars.
All right. Bye-bye.
Bye.